Hey everyone, and welcome to day 49 of 100 Days of Code in IoT Challenge. I'm Thomas, and this is the channel that educates you on IoT and web development by showing how to build projects step by step. Today, I'm gonna continue working on a snake game. My goal is to display snake on the screen, make it move, and control its moving direction. So let's get started. Okay, first of all, before I continue coding, I'm going to summarize what we've got so far and also remind you where we finished yesterday. So what I've got is a struct called snake with the enum called direction, right? For up with the values of up, left, right, down. Snake has a constructor that takes width and height, and based on those, it determines the coordinates of the head and tail, and also sets the default direction. We've got a set direction method. This is where I finished yesterday. I created that method to make possible setting the direction, which is encapsulated here, right? It's a private, so there is a way to do it from the outside. We've got two methods to get the head coordinates and get the tail coordinates. I even created an instance of it, but that snake cannot exist on its own. It has to have some sort of a reality for the snake, and that reality is the game, right? Which is, by the way, you see, as a friend of a game. That means game has access to the private members of this class, of this object, and the game itself. What it does, it has a constructor that takes a snake, a reference to snake. It has a pixel, move snake, so this is where we're going to move our snake. That's gonna be the method I'm going to implement in a minute, but I also need to do a constructor. And it's got a field. And what the field is, let me explain it again. So what the field is, this is essentially the field, a two-dimensional array that consists of the elements of an array, and most of the elements, especially at the beginning, are empty, are zeros, right? They all pixels, enum pixel, as you can see here. That's the representation of those fields in that two-dimensional array. And as a default, they are all empty. But they're not always empty, as they sometimes represent the snake itself, right? They can represent the head of the snake, the body, or the body of the snake. The way they represent the body of the snake is with the relative directions, right? The relative directions to the previous segment. So the way this is actually represented, let me show you again and remind you. If we have a snake like this, where this is the head, this is the tail, right? All of the segments contain a specific enum value. And that specific enum value is the direction to the previous segment. So if we start from the tail, the previous segment from the tail, right? This is the last segment. This is the first segment. So relatively, the previous segment from the tail is on the right. So this is gonna be right? It's gonna have a value of 3. Then previous segment to this one relatively is right again. This one is right again. This one is up. So I'm gonna use U. This one is U, up again, and now we've got right and right again, and head is just a head because we don't know the direction yet. The direction is set on the snake, and this is gonna be determined in the move snake method. This is it for the summary, and now let's continue working with the code. So now we're going to implement move snake, okay? So to move snake, what we care about is first of all the snake direction, right? But hang on, can we move it? We cannot move it because we don't have the snake represented on the screen at this point, right? So I'm still gonna use that spreadsheet to show you what's happening with the code right now. So at the moment, if you create the game, that's just gonna be an empty an empty array, right? Two-dimensional array. So when we pass the snake, what we're gonna have to do is to get the information from the snake, and we can get it from the head and tail, and we're going to draw it, right? Just in the memory though, that it doesn't draw anything in here. Drawing is on the TFT, but that's gonna be separate. I would like to keep it separate from the game logic. So game, what can we do is to write a for statement that is gonna be for the x, and that x equals as tail first, right? We want to get the tail and x. Could actually access it straight away, but that's fine. And that's gonna end up on head x, right? And then we do x plus plus. And here what we're going to do is to run field, the private member. So we're gonna do field x, and for the y we can get any of those, right? So it can be head y or the tail y, doesn't matter. And what we would like to do is to, because we're starting from the tail, we would like to write a straight line. So that's what I want to do. I'm gonna start from the tail, and let's say the tail is 7, 10, right? x7, y10. And what I want to do is to write, let's say the head is here. So I want to write r, and h at the end, right? So it's gonna be right, until it gets to the head, which is actually, this is wrong, because that should be just before the head. And once we are at the head, so that's gonna be exactly field as get head dot x and as get head dot y, that is gonna be our head instead. Okay, so that allows us, when we create the structure, the game, passing the snake, right? The reference to snake, that's what's going to be drawn in the memory, right? That's how it's gonna fill up this two-dimensional array. So that's what's happening in the constructor in here. Nice, okay. And now we've got it in the memory, but we would like to be able to move it. And to move the snake, what we wanna do is to check the direction first, okay? So I'm gonna do switch, and that's gonna be on the snake itself. And we should be able to get direction. We don't have get direction yet. So let me do it as well. Get direction. Okay. So we can get direction. And now based on the direction, right, we can basically move the snake. And moving the snake is gonna be like I showed you. So we're going to draw a head in front of the snake. So let's start from the direction that's gonna be on the snake though. So we have snake direction up. We're gonna start from up. And let's have a look at the image, at the spreadsheet again. So we've got our head in here, and the direction is up. So what we want to do with the x and y, if you look at the y, right, that changes. X stays the same. Here is x, here is y. And what happens with the y? It goes down, right? It's decreased by 1. So what's going to happen in here? We're going to do snake. Come on. We're gonna do snake head. And again, what it was? That was y, right? Y minus minus. And this is essentially what you change. However, if I do just that, then what's going to happen is the change of the snake itself, right? That's just changing of the snake. We know where is the new head, but we still need to change those fields in this field array, right? And in order to do that, first of all, what I would like to do is to change that, right? Change that actual one to the relative value of the previous segment, which is going to be the head. Because we're moving up, this is where the H is gonna be. That needs to change to up, right? And then we're going to add head. So we need to add two values to it. I mean, change one value and add one. And that's gonna be on the field. So field snake. We can actually do, we can do snake get head dot x and snake get head dot y. That is gonna be the direction, right? So snake. Actually, no, it's not snake. This is a different direction. That's pixel, right? So pixel up. That's gonna be pixel up. So now we change that to U, and now we need to do H. And to do H, we're going to field snake dot get head. That should be like that. X stays the same, isn't it? Right? X stays the same. It's 14, but Y changes. And that Y changes is essentially how we're gonna do it, right? So that's gonna be pixel head now. So this is essentially what I've done, right? It used to be like that. And what I've done is to change that to U and add a head here. Okay, and then store that information about the head on the snake head itself. Right, this could be even simplified, because if you look at that, what I can just do is to do that first and then do that. But I think this one is actually more readable, because we doing the changes on the field first, and then we change the snake head coordinates. And that's it. That's for the direction up. And for all other cases, that's gonna be pretty similar if you think about that. So we will have snake direction left, and for the left, we're doing almost the same thing, but there is one change. And that change is, if you look at that now, let's add maybe another one. And now we want to go left. So what's going to happen? We change this to left, and then we put H in here. How to calculate H? What is the relative change? The relative change at this point is only on the X. The X decreases if you go left. So that's what we want to do instead. So here it's gonna be X minus 1. Y doesn't change. And because X is minus 1, we're gonna do decrementation on X. Okay. I hope this is clear enough for you to understand. Right, so we go left, and I'm gonna do right now. And I'm gonna do down. Should be down as well. You know what? I can do this as default. I don't expect to get anything else, but yeah, just in case. Right. Is it too much or something is wrong? No, that's correct. Yeah, one thing to fix though, also, that should be pixel left, because we know we're moving left. That should be pixel right, because we're moving right. And that should be pixel down, because we're moving down. Do we have down here? Yes, we have. Okay. There's clearly something wrong with the code. Okay, I see. Okay, that is correct. Okay, so again, so we have up, we decrease -1, y by -1. Here we decrease x, and now for the right, it's gonna be opposite to left. So we're going to do x plus plus, and here is gonna be x plus 1. For the down, right, that's down by the way, what we want to do is the opposite of the up. So we're going to increase y. So here is gonna be +1, x stays the same, and we're gonna do y plus plus. Okay, yeah, let me show you this on the, let me show you this here on the spreadsheet. So now let's say I'm going up, right? So going up, what happens? Y changes from 8 to 7. When you go left, what happens? X changes from 13 to 12. So that's -1. If you move right, that's +1, 12 to 13, right? So you can essentially tell just by looking here, right? So that is decreasing x, this is increasing x, this is decreasing y, and this is decreasing y. And this is exactly what is represented in this switch case statement. Okay, so that is to move our head. That is to move our head. But don't forget about the tail, right? We don't have the tail calculated yet. And for the tail, it's gonna be slightly different. So what's gonna happen for the tail is, first of all, what we have to do is to tell what is the segment before the tail. Okay, we have the tail information on the snake itself. So what I can do is to assign it to two variables. So we will have snake get tail x, and the same thing I can do for y. The same thing can happen for y. And now what we want to do is to check the information on the tail first, right? So we want to know what is the previous segment. That is easy. We can get it. We can get it from the field. Okay, so we can get it from the field using tail x and tail y. Why I assigned it to variable, I'm gonna show you in a second. So this is gonna tell us what is the relative position of the previous segment, of this segment, right? We're trying to remove this one. And what is this one? Where is this one, right? Here we're gonna get R. If we are here, we're gonna get R. That means it's to the right. So again, there's gonna be switch case statement, but this time it's not gonna be on the snake direction, but this time it is on the pixel, right? On the pixel. So if we have pixel, let's start from right, because it's gonna be easier, right? So right, that should be case. So if we have case right, then what we want to do is to change snake tail to this new position, right? And if we know it's right, if it's right, then x increases. So the only coordinate that we want to change is the x itself. We can just increment it. Okay, so that's what's gonna happen here. And that's it. If it's left, it's gonna be easy. It's all the way around. So we just change snake tail dot x, but minus minus. Okay, that's going left. And now we have pixel top up, and that's gonna be just y changing, and y changes decreases, right? It's going up, like I showed you before. Going up means decreases, right? That value decreases, the y value decreases. So we're gonna have y minus minus. And the last case for going down, it's going to be increase instead on the y, right? That's opposite to up. Okay. So this is how you change the tail, but this is not the end, because that is going to change the information on the snake only. We also need to actually remove that bit, right? That's just gonna change something outside of this two-dimensional array. We need to remove this one. This is the one that we want to remove. But that is pretty straightforward because we stored the values beforehand, right? That's changed, by the way, you see. Now if you do here get tail, you will get the new value. We need to have the old value. That's why I created those two variables. And right after the switch statement, what I can do is to do field tail x and tail y and change that to empty. This is it. So that's how this is how you remove the last segment of the snake, the tail, right? You change the location of the tail and you remove the last segment. So this behavior from here represents exactly that. So I moved the snake already, and that's basically what it does. We have RT here, and what it does, it changes that to RT. That is not RT anymore, but stays as a R, and it's removed. Okay, so that's what happens in here. Cool, okay. Is this everything? No, that's not everything. There's few more things, very small ones though, because that's the most important logic. That's the main logic for the snake to move on the screen. But yeah, hang on. Before I move to drawing the snake, because that's gonna be the next step. Now we can essentially draw it on the screen, on TFT screen. But before I do that, let me do some housekeeping. So this move snake thing, that can go to, I can create two private methods. So I'm gonna call it move head and move tail, because they really separate, right? So this will go to move tail, and this will go to move head. Right? And in the move snake, we're going to do move head and this move tail. Right? Okay. Okay, cool. So yeah, now we have a snake created already, I think. 1 second. There we go. A snake is a friend of the game, but snake needs to be also defined before the game, otherwise the game is not gonna know about snake. So I need to do struct snake. Cool. And once we have a snake created, I'm gonna do game, and I'm gonna call it game and pass a snake here as an argument to the constructor, so it can construct it. Right, let's see if this code compiles, just in case. Okay, something wrong. Let me see what I missed. Okay, that's my fault. That should be void, right? Should be void. That should be void. And something wrong with the snake itself. So what is wrong in here? That's not the one. This is the new one. So we have as get tail, invalid use of incomplete type struct snake. Oh, I guess that has to be other way around. So we will do struct game. And we move the game over there instead. Let's see. Okay, now we've got just one error. And yeah, that's the problem with the field in here. Okay, so you see some mistakes I have done on the way, but minor ones. Okay. So yeah, now that compiles. Okay, and now what we can do is to actually start drawing it on the screen, because this is just the logic of the movement of the snake. And now let's do the other thing. Right, so for the buttons, pretty straightforward. What we have to do is to just go for the snake and set direction. And we need to set this to a snake direction that's gonna be up, right? Here we have down, left, and right. There is no delay that we have to do at this point, but it's good to have a delay at this point, maybe slightly less. Okay. And here we're going to draw a pixel and remove the previous one, right? The one from the tail, but I've just realized there is no snake on the screen yet. So I'm going to draw it. And I'm gonna do it the simplest way. So I'm not gonna create any function for now. We're just gonna have x that equals to snake get tail. We're gonna start from tail x. Then we will have x less or equal snake get head x and x plus plus. And in here we're gonna do TFT draw pixel, and we're gonna do x and y is going to be snake get head and y, and the color is gonna be white. So that is actually draw snake, right? So that draws snake at the beginning, and now adding and removing the pixels. So adding, removing the pixels is pretty straightforward if you think about that. So we're gonna start from drawing a new one. To draw a new one, what we're gonna have to do is to do game dot move snake, and then what we're gonna do is to run TFT draw pixel, and I can just use the snake coordinates of the head, right? So there'll be snake get head x, snake get head y, color white of the pixel. So yeah, we have draw pixel, that draws pixel, but yeah, removing the pixel. I think removing the pixel needs to happen before we move the snake, because literally moving the snake is going to change. Yes, that has to happen before. So that'll be TFT draw pixel. Again, we're gonna draw pixel, but it's gonna be black pixel. So snake get tail this time. And this is given that we're not really eating any food as a snake at the moment. So that's gonna have to change at some point. And we're gonna give a color black, right? Nice, okay. So yeah, now with this functionality, if you think about it, what is happening? So we initialize the game and the snake. At the beginning, our snake is just a straight line that is 7 of length, right? It starts in the middle -3 and ends at the middle +3 on the x-axis, right? The y stays the same as in the middle. That's how it starts. And it's a part of the game. And that game itself also represents that snake on its own field, right? Which is in here. Which is in here, right? By the way, I've just realized it would be nice to change that to pixel. Okay, so we have now field of pixels, and what we do in the setup, we draw the snake based on the snake tail, the initial tail coordinates and head coordinates, right? Just the x coordinate for tail and for head, and a y coordinate for y, because they should be identical at the beginning. Here is to set the snake direction. So we use the buttons to set the snake direction, right? To change it, essentially. And here, what is happening? Because the snake is about to move, we're removing the actual tail, right? We remove the tail, getting the coordinates from the actual tail coordinates, because we know after the movement, this is not going to be the tail anymore, right? It moves 1 pixel left, right, up or down. So we're removing that pixel. Then we do the actual move snake, this is where the logic happens. And then we draw the new head. So that's gonna make the movement. We have a delay of 75 for the snake to not be too fast on the screen. This is essentially the speed. I can even define it as a speed. So we will have something like that. So speed. Define speed, and there's going to be 75. Okay, but that's the other way around. The higher it is, the slower it is. So it's not really so that's not the speed you would measure like with velocity, right? It's not higher the value, higher the speed. No, that's the other way around. Okay, so I think I can let me just compile it, and I think what I can do, if it compiles, yeah, there is something wrong. So that's probably on the enumeration. So enumeration value empty, not handled in the switch. Enumeration value had not handled in the switch. So this is probably something with, yeah, I might use default in here. I'm not sure if this is why we have a linker error. No, that's not why we have a linker error. So let me check that out. Okay, yeah, it looks like it doesn't like the type pixel here. So I think now I could even change that to down, but yeah, let's keep it as a default for now. So that is down like I did in the other example. Now the code compiles. So I'm going to deploy it. Okay, the code is deployed and we can see snake moving on the screen. I'm gonna move to the top, then left, down and right. So that seems to be working well. However, let me check what happens if I go left and then I try to turn right. Okay. Looks like the snake has lost its body, right? It's lost its tail. Let me show you how to fix it. Okay, and to fix this bug, it's something I've known about before, but I just wanted to show you what happens if we don't take it into account. To fix that, I actually prepared everything to fix that, because we can change direction only through this method, right? Void set direction. And in here, what we're gonna need is, I mean, you know, direction d equals d can stay, but what we're gonna need is an if statement, and that if statement is as such. Okay, a bit complicated. That should be on direction. So as you can see, if direction is up and d is down, right? I can rename it to new direction maybe. New direction. Yeah, so that's better, right? So if direction is up and new direction is down, or direction is down and new direction is up, or direction is left and new direction is right, or direction is right and new direction is left, then we don't do anything, we just return. Otherwise, we set the direction. So we need to have not the opposite direction, okay? I guess this if statement can be optimized. I just, did it quickly, but I think it can be optimized with the numbers. I'm not gonna do it now though. So yeah, so I'm gonna deploy it now, and I'm gonna show you that this fixes the bug. Okay, deployed. Let's see if we can change the direction. Yes, we can do. And now I'm gonna check if I go right and then try to go left, anything bad happens. No, obviously not. The other way around. It's also not changing direction. If I go top to the top of the screen and then try to go to the bottom, as we can see, there is no response because of the if statement that I have put in my code. Nice, okay. Yeah, there is one issue right now. If I try to go outside of the screen, the program is probably gonna crash because we haven't started calculating the collisions yet, right? But that's the subject for tomorrow. And this is it for today. Tomorrow, I'm gonna show you how to calculate collisions. So when snake hits its own body or it hits the wall, right? We're going to do game over if it happens. And yeah, thanks for today. If you are interested in this type of content and you find this useful, don't forget to subscribe to my channel so you will stay up to date. Cheers, bye.